All right, let's tackle one of the most common and honestly one of the most revealing technical interview questions you're ever going to face. By the time we're done here, you won't just have an answer. Oh no. You'll have a complete strategy, from a killer opening line to the real-world stories that prove you're an absolute pro. So you're in the interview, everything's going great, and then it comes. This question. Now it sounds simple, right? But your answer, it tells them everything. How you think, how you build software, and really how professional you are. So how do you totally nail it? Here's our game plan. We're going to look at why this question is so important. I'll give you the perfect one-liner to kick things off, and then we'll get into the why and the how with a 5-step process, a real-world example, and the best practices that'll make you really stand out. First things first, let's be super clear. When an interviewer asks this, they are not looking for a definition you memorized from a textbook. What they're really testing is your entire professional mindset. Are you disciplined? Do you actually care about code quality? Do you have a process? Your answer tells them all of that. You know, the secret to a fantastic answer is starting strong. You need a concise, powerful opening that basically summarizes your whole philosophy and skill set before you even get into the nitty-gritty details. It just screams confidence and clarity. So what does that perfect opener actually sound like? Let's take a look at the one sentence that's going to be the core of your entire response. This right here, this is your foundation. And there it is. Just look at how much work that one little sentence does. It covers the purpose, which is validating business logic. It names the tools, like xUnit and mock. And it states the outcomes, code coverage, fast feedback, and safe refactoring. It's a perfect, neat little summary. Okay, so you've dropped that powerful one-liner. Now it's time to unpack it. And the first part of that is explaining the why. I mean, why do we even bother with unit testing in the first place? Let's break down those core objectives. The really important thing to get here is that unit testing isn't just about finding bugs. It's about building a safety net. And this net, it makes sure our code does exactly what it's supposed to do, gives us confidence that our logic is covered, makes the code way easier to maintain down the line, and this is a big one, it lets us refactor our code without that constant fear of breaking something. So after you've explained the why, you've got to prove you know the how. This is where you walk them through your actual process. Having a structured step-by-step approach shows you're not just winging it. You have a professional framework for writing quality software. This 5-step process is basically your blueprint. It all starts with designing code that's even testable in the first place. Then writing the tests, dealing with dependencies, measuring your work, and finally automating the whole shebang. Let's dig into each step. This really gets to a key idea. You can't test messy, tangled-up code very well. It's just a fact. Great testing starts with great architecture. So when you use established design principles, like solid and dependency injection, you're naturally creating code that's modular and easy to isolate and test. You're setting yourself up for success before you even write a single test. Okay, so you've got testable code. Now you need a pattern for writing clean, understandable tests. And the gold standard for that is arrange, act, assert, or just AAA. It's a super simple structure that makes every single test readable and focused on one specific behavior. The first A is for arrange. This is your setup phase. It's where you create all the pieces you need for the test to even run. You might be creating a mock object or initializing the class you're about to test with some specific data. Basically, you're setting the stage. Next up is act. And this part is beautifully simple. It should really just be one line of code where you call the one specific method that you're testing. All that setup work you did in the arrange phase leads to this single, focused action. And finally, we assert. After you've acted, you have to check the result. Did the method actually do what you expected it to do? This is where you verify the outcome. And using a library like FluentAssertions can make these checks incredibly readable, almost like you're reading plain English. Now, this is a really critical step. A unit test should only test one unit of code, right? Well, that means we have to isolate it from outside systems like databases or APIs. We do this by mocking them. We create these fake, controllable versions. And this makes our tests lightning fast and super reliable because they're not waiting on a slow network connection or a database that might be offline. Step 4 is all about measurement. You know, how much of your code is actually covered by tests. The sweet spot is generally somewhere in the 70 to 85% range. Honestly, chasing 100% usually leads to writing really low-value tests just to hit a number. The focus should always be on quality, covering your critical business logic and all those tricky edge cases. And the final step, well, this is what ties it all together. You automate your tests within a CI/CD pipeline. What this means is every single time a developer tries to merge new code, all the tests run automatically. If even one test fails, the build fails, and that broken code is blocked from ever making it out. It's the ultimate safety net for the whole team. Theory is great and all, but a real-world story is what's going to make your answer truly memorable. This is where you prove you haven't just read about this stuff, you've actually done it. So let's walk through a concrete example. So imagine you're working on a new payment feature. You'd start by writing unit tests for every single validation role, like checking for a valid credit card number. You would then mock the external payment gateway so you could simulate both successful and failed transactions. And because you did all that, you'd catch these weird, quirky edge case bugs long before the code ever gets near the QA team. And what's the end result of all that work? Tangible business value. The feature goes live with 0 issues in production, and the QA team can sign off on it way faster because they already have a high degree of confidence thanks to all those automated tests. See? This is how you connect your technical skills directly to business outcomes. And to really just seal the deal, you can finish up your answer by summarizing a few key best practices. This shows you don't just think about how to test, but how to test well. These are the principles that separate a good developer from a great one. Okay, pay really close attention to this first point. Test behavior, not implementation. This is so crucial. You want to verify what the code does, not the nitty-gritty details of how it does it. This is what keeps your tests from breaking every single time you refactor something. And the other points all support this main idea. Keep tests readable, name them clearly, and don't get crazy with mocking. It's all about clarity and making sure this stuff is maintainable for the long haul. So there you have it. We've broken down the perfect answer from top to bottom, from that golden one-liner to the 5-step process and the real-world proof. The structure is all there. The only question left is how are you going to use this framework to not just ace your next interview, but to fundamentally build better, more reliable software?